Welcome everybody. Today our lesson will be about something we use every day in our daily life, which you call the lever. Actually, you could call any manual tool you hold and use lever. Examples on levers which we use in our daily life: the hammer, the pincer, the plier, nutcracker, the manual broom, the crowbar. The definition of lever. Since manuals levers since more 1,006 years, no one tried to define it. The first scientist who described the lever and gave a definition for it was Archimedes in 260 BC. According to his definition, lever is a rigid bar that rotates around a fixed point called fulcrum and is affected by an effort force and resistance force. So the structure of levers: effort force, resistance force, fulcrum. First, the effort force. It is the force which done by person use the lever. The effort force found in the part of the tool which a person hold. Look at the image in front of you. There is man hold a hammer. The place in which the man holds the hammer is the effort force. So, effort force is found in the point which we applied force. It means we hold in our hands and use the lever. Second, the resistance force. The force resulted on the load or body which is moved or crushed. Examples on the position of resistance force: in the image in front of you, there is a hammer is hammering a nail. The part of the hammer which you hammer the nail is express the resistance force. In the image below it, there is a nutcracker. The part in which the nut is broken is represents the resistance force. And here a holder hold a piece of cake. The place which you hold the piece of cake, it represents the resistance force. Fulcrum, it is a fixed point that rotates. It is a fixed point, lever rotates around it. Actually, the fulcrum is the point which you connect between effort force and resistance force. And now, let's answer some questions together. Complete the following. Space is a rigid bar rotates around fulcrum. The answer is lever. Lever consists of three parts which are effort force, resistance force, and fulcrum. From examples of levers, of course you could say any two examples as hammer and nutcracker. The first scientist who described the lever was Archimedes. Space is a fixed point where the rigid bar rotates around it. The answer is fulcrum. Is the result from the weight of the body which you want to move? The answer is resistance. Now transfer to the importance of levers in our daily life. Number 1, increasing the force. you could use small force to obtain large force. It means by using force to move heavy loads or affect them. Example in crowbar. Look at the image. This worker could move this big stone by crowbar. It is difficult for him to push it forward or move it by his hands. In the second lever, if you want to break a nut by nutcracker, you will easily do it. But if you try it by your finger, it will be difficult for you to do that. Increasing distance. Example, manual broom. Manual broom could collect garbage around it, as distance around here and here. So manual broom increase distance. Increasing speed. If you throw this ball with your hand and the other time you hit it by this hockey bat, compare between the speed in two cases. Of course, in the second case it will be faster. So hockey bat increases speed. So the function of levers increasing speed. Accuracy in performance. If you try to hold very small object like very small nails, it will be difficult for you, but you could use tweezer to hold them easily. Avoid danger. Of course, you couldn't carry in your hand this burning coal. So coal holder help you to do that. And it's easily for you to to carry ice with ice holder instead of your hands. Types of levers. There are 3 types of levers. Actually, we determine the type of lever according which of the part of lever found in the middle. It means which in the middle, fulcrum or effort force or resistance force. So there are 3 types of levers. Number 1, the first class lever. In first class lever, fulcrum lies between effort force and resistance force. Example, crowbar. Look at this example. Fulcrum is in the middle, and here is the rock which we want to move. This place represent resistance force, and here is effort force. Pincer. Here is effort force, the part which we hold with our hands, and here is resistance force. The scissor is the same. Fulcrum in the middle, and here is resistance force, the position which we use to cut papers or cloths, and here is effort force, the part which we hold with our hands. Another example, the hammer. Here is effort force, the part which you hammer with it is called resistance force, and between them is fulcrum. second class lever. In second class lever, the resistance force lies between fulcrum and effort force. Example, nutcracker. Look at nutcracker. The nut is in the middle, and the part which we hold with our hands is effort force, and this point is fulcrum. Bottle opener. Similar to it. Here is effort force, resistance force, and here is fulcrum. So resistance force is between fulcrum and effort force. Another example, wheelbarrow. Look at wheelbarrow. The part which the worker holds with his hands is effort force, and here is resistance force, and this point is fulcrum. Now the turn of third class lever. In the third class lever, the effort force lies between fulcrum and resistance force. Example, ice holder. Look, the part which you hold the ice is resistance. Effort force is in the middle because the man hold it with his finger from the middle, and the last part is fulcrum. Another example, cool holder is the same. The man hold it from the middle, so is effort force. Here is resistance force, and here is fulcrum. Tweezer or tongs is the same. Fulcrum, effort force, resistance force. Let's answer some questions with each other. Write the scientific term. A rigid bar rotates around fixed point called fulcrum. The answer is lever. The fixed point which is found in the lever. The answer is fulcrum. A point in the lever which force affect it. The answer effort force. A point in the lever which contains load. The answer is resistance. First scientist who described lever, Archimedes. Complete the following from importance levers: increase distance, increase speed, increase force. Number 2 space is from the levers which increase force. Crowbar, nutcrackers is a lever increase speed, as hockey bat is a lever increase distance. The answer is manual broom. Number 5 from example on first class levers: scissor, hammer. From example on second class levers, you could say any two suitable examples as nutcracker, bottle opener, wheelbarrow. For example, third class lever: tweezer, ice holder, cool holder. Mention one example for each of the following. A lever increase force. Crowbar. A lever increase distance. The answer is manual broom. A lever increase speed. The answer is hockey bat. A lever avoid dangers. Answer is cool holder. Lever used at accuracy in performance. The answer is tweezer. First class lever. Hammer. Second class lever. Nutcracker. Third class lever. Cool holder. Goodbye, and you will find the sheet of the lessons below the video of the lessons. Thank you and goodbye.